Let's look at the concept of power mathematically. Power is defined as the amount of work done on an object over time. This is the first time that we see time become a factor in our energy unit. And the unit of power is the watt, which we abbreviate with a capital W. So if you see something like 50 capital W, that means 50 watts, and that is the power. The work done on an object is equal to its change in energy. So quite often we're going to do problems where you say something like, hey, I've got a guy who's going to climb a ladder, and the ladder has a certain height, and he's going to do it in a certain amount of time. So the work we do climbing a ladder is giving us potential energy. So you could say, well, if you have zero potential energy at the bottom, and at the top we have mgh worth of potential energy, then the work done is just the gain in potential energy. And so the power in this situation would be the potential energy we gained over time. You can also talk about the amount of power involved in changing the kinetic energy of something. So you could say, we're going to take a car and accelerate it from a speed of 0 up to some other speed, which will give it a kinetic energy of 1/2 mv squared. And if we do it in a certain amount of time, how much power is required? And then you would, for work, substitute in the 1/2 mv squared over the time, and you would have the power. Working with power is pretty simple. You just have to take the energy change divided by the time, and that's your power. One other thing to consider, since power is work over time, work is force times displacement, and you can put that over time. If I look at the displacement over time, I can kind of rearrange this so it's the force times the speed, because displacement over time is speed. So if you have something moving at a constant speed, power can also be expressed as force times velocity. One example that I can think of is an elevator. If you have an elevator and you've got a cable towing it up and you're moving it at a constant speed, you know that the tension in the elevator cable has to be equal to the weight. And so you might have a question that says something along the lines of how much power would be required to move an elevator at a certain constant speed. Well, since power can be expressed as force times velocity, the force required to move it at constant speed would be equal to its weight, and then that speed would be multiplied in to give you the power required by the motor that operates the elevator.